So as you can see, it does say in our I can statement, I can describe how wind is produced. I can describe the types of winds. And the reason why you want to do that, Braden, is you want to be like, I can describe the types of wind, how it's produced, and what it does in order to predict how that's going to affect all of the weather patterns across the entire globe. Okay, obviously we're mainly going to focus on us, but these winds are not called North Carolina winds. They're called global winds. The air masses that we're going to talk about are not called North Carolina's air masses or Wahlberg's air masses. They're called global air masses. And so this gets into a pretty large scope, but I think you guys will be able to handle this. The first thing we need to look at, and everyone has access to a blank like Earth, right? Put it on your desk. If I'm not mistaken, it should be two-sided. Just put it on your desk. It should be an Earth on one side and an Earth on the other side, correct? It's blank on, it's got Earth on two sides for a couple of reasons. One, we're going to be taking a whole bunch of notes. And if Nicola decides to write all of this on one side, I think she would probably end up getting confused. Because there's going to be a whole lot of information, and I think she would probably get confused after a while. Maybe. I guess if she's really good and she takes super detailed notes, she could probably do it all on one side. But I would personally not do that. Now, the first thing we need to talk about is the latitude and longitude. We hear those terms. We've seen them. I'm certain if you look at this example of the Earth down here, you're probably like, yeah, Mr. Bullens, I've seen things like that. I recognize probably one thing on there for certain. What's the one thing down here that you most definitely recognize that we've talked about in class before? Certainly not the prime meridian. Certainly not latitude or longitude. There's a word in there, though, that we have talked about very often. Jada. The equator. The equator. We've mentioned that very often in class. And it's going to be mentioned even more so today. But we want to start off with longitudinal lines. And the longitude lines are the ones that run vertically. And that means the ones that go up and down vertically. The way I remember that growing up was they were always talking about different basketball players and what their vertical was, how high they could jump up. So I always remembered up and down. So I'm going to take my map, and I'm personally going to draw some lines on here just so that I can remember what they are and what they mean. If you notice, if you look at the picture, well, I'll look at that in black. I don't think blue would be very good. If you look at the picture here, right, there's no way that I can sit there and draw all that perfectly, all right? But I just want to put something in here about longitude lines are the ones that run vertically. So I'm going to do the best that I can, which is all I can ask you to do. Somewhere, I just need you to understand that longitude are the vertical lines. Longitude are the vertical lines. Go back and look at this. Do I need you to remember all this stuff about 180 degrees and 360 and all of that? Not necessarily. Do you need to understand all that? I'm kind of describing down here what it's doing and why, but you don't have to measure any of that. Does that make sense? I'm not stressed about this right now. Now, the very weird thing about this, though, is these lines go up and down, but they're measured in east and west. Right? It sounds like they would be measured in north and south. Correct, Dawson? Supposed to go up and down, it should be north and south. But if you look at this, if I just say, like, I can't tell you where on this line is. I can just tell you where the line is, right? And I could, let's just say if this happened to be my main line, if this one was the main line, I could say west of that line or east of that line, correct? So, oh, okay, Mr. Bowens, that makes a little bit more sense. It's a little weird that they go up and down, but I understand how they are measured in east and west. And what you're really looking at is this thing here in the middle called the prime meridian. The prime meridian. Is that going to be on the test? No. I just want you to understand these are measured in east and west. Important ones? Yes. They are important because I don't want you to get them mixed up with this next one. This next one is latitude. And Braden, latitude is going to show up all the time. All the time. And I'm going to show you probably the biggest reason why latitude is the most important of the two, in my opinion, for us right now. I'm going to do this in blue because I want it to be a little bit more prominent than the other one. What line, actually I need to be darker blue than that, and maybe a little thicker. What line is this? And why is this line maybe a little bit more important than that other line that we looked at just a second ago? What line is this? It is a horizontal line, but what is that? On the Earth, and Jada already told you, Nicola, that is the equator. Oh boy, does that play a huge difference in things? Yes, because that's where the sun has the most direct contact with the Earth, and it's usually generally warmer at the equator all year round, right? That's where we learned in our ecosystems, that's where we're going to find most of our tropical rainforests. Now, these lines also, they're running horizontally. That means side to side, so they look kind of like this, roughly. Roughly. So these are my lines of latitude. They go horizontally. Now again, Noon, this is a little weird. Once you've got these lines that run horizontally, but I measure them not in west to east, but in north to south. Oh boy, can that get confusing, right? But let's think of it. Here's my equator. I'm going to make that even darker. If I can. Well, let me do that. I want my equator. There we go. Could you see how someone could tell you that something is north of the equator or south of the equator? Yes, Mr. Bowens. All of a sudden, these lines of latitude and longitude are starting to make sense, aren't they? Now, here's the really cool thing about these. If I take the Earth away, and I roughly sketch what we just did. Whoa, not like that, Mr. B. Holy cow. Where's the back button on that? And I roughly sketch what we just did. I have lines that went up and down. Those are called my lines of longitude. I have lines that go horizontally, and those are called my lines of longitude. Have you ever seen anything similar to this in math class? It looks like a graph, doesn't it? Can you plot points on a graph? Okay, if you understand that, then it would make a little bit more sense to you. Can I plot points on the Earth using latitude and longitude? So when somebody gives you the latitude and longitude, it's almost like playing Battleship. They are literally putting you somewhere north and south, and then somewhere west and east, but they're putting you on a very specific spot on a line of latitude and a line of longitude that tells you exactly where they would fall. Does that make sense? Exactly where they would fall. So that's how we get our readings on lines of latitude and lines of longitude. And I know, we've just spent like 10 minutes describing this, but the big important thing about this is you really need to understand the different like zones that are going to come up out of this. All right. So I'm going to go back and take a look at my Earth once again. Maybe. There we go. Now, if I were to kind of like cordon these off into different zones, I'm going to use this. And that's probably pretty good. Nope, I need to use the highlighter. And pretty thick on that. Here. And, well, maybe not quite that big, but it is what it is. Here are two zones. And we know that these are what? What areas would we label these as? If you had to label them, what are those? The polar regions, right? That needs to be a lot thicker than that. And maybe even thicker than that. There we go. Polar regions. What kind of air do you think we have in the polar regions? Cold air, but there's a word they use for it, frigid. Mr. Bones, how am I going to remember this word frigid? I've never heard that before. You sort of have. Where do you keep a lot of stuff that needs to be cold at home? The refrigerator. So you can remember the word frigid. I promise. I promise you can remember the word frigid. Now, we know that this area in and around the equator is going to be very warm, right? So if I get my red highlighter out. And I color all this in. We call this area here. There's a couple of things that we could talk about this area. What do we say about this area in general? It is very warm there. You are correct there. Very, very warm. What else? What else? What else is here? It is. These are called the tropics. This is where your tropical islands, not all of them, but a lot of them would end up being. This is the tropics. Now there's a very odd word that they use in here that we may not have heard before, but luckily it starts with a T. The tropics is very hot. You can put that in there. It's hot there. But there's a word they use for that called torrid. Just in case that pops up again, that is going to be considered your torrid region, your hot region. Now that leaves quite a large area, right? I'm going to color that orange. Probably color that a different color, but orange is going to work out just fine. There's something very important for you to understand about this orange region. One thing is, you live here in this region. Now, you know what happens if you live here. Do they give a lot of questions about this region? Yes. I mean, how much does Lila really need to know about the poles, seeing that it doesn't affect her daily life? Probably not a lot at all, right? Probably not a lot at all. So what I'm going to do is I'm going to stop this video and pick it up again with another video.